Good morning, sir. My name is Bodha Sabshek. I'm from EC department, linear IC applications. My topic is about low complexity rate compatible modulation with hybrid bit set. Today's topic is introduction to low complexity rate compatible modulation. Low complexity modulation schemes are essential for efficient communication systems with limited processing capabilities. Also, rate compatibility allows modulation schemes to adapt to varying channel condition and data rate requirements. Hybrid weight sets are used to optimize the performance and complexity trade-off in modulation and low complexity at receivers, especially in BPSK, QPSK, and also rate compatibility punched codes. It starts with a low rate mother code, increase rate by puncturing bits, used with HARQ for incremental redundancy. Low decoding complexity will be in rate compatibility, and it combines coding plus modulation in rate compatibility. The next is motivation and application. Modern communication systems such as IoT has IoT and 5G demanded flexible and low complexity modulation techniques. It is also network conditions without residue systems. Utilizing hybrid weight sets can improve spectral efficiency and robustness in diverse operational environment. Such in modulation there are schemes modulations. AM modulation means amplitude modulation, ASK amplitude shift keying, and FSK frequency shift keying. These are the modulations, and it's also in good for linear ICS. In AM modulation, very simple and multipliers. Amplitude shifter keying easy with comparative and switches. BPSK can be done with analog multipliers, and it is practically also low complexity. Ask simply hardware. These are the motivation and applications in modern communication systems such as IoT and 5G demanded flexible and low complexity modulation techniques. Rate compatibility modulation enables seamless adaptation to changing network conditions without residuing the system. The next topic is a fundamental of modulation and coding. Modulation maps digital bits onto single waveform, influencing systems complexity and performance. Coding adds redundancy to protect against errors with rare compatibility, ensuring adaptive coding rates. Combining and modulation and coding techniques leads to efficient and resilient communication system. Is also adaptive motion and adaptive modulation and condition switches modulation. These are the fundamental modulations and coding. Uh, it starts with a low rate mother code, increases rate by puncturing bits, used with HARQ for incremental redundancy, low decoding complexity, bit interleaved coded modulation. Combined coding plus modulation is a fundamental of modulation coding. Concepts of rare compatibility in modulation. Rare compatibility modulation schemes are designed to support multiple data rates with a single framework, and they enable incremental redundancy which improves the decoding process under poor channel conditions. Implementing rate compatibility reduces system complexity, avoiding multiple separate modulation. And here the modulation schemes: analog modulation, AM amplitude modulation, FM frequency modulation, PM phase modulation. These are the analog modulations, and it's a sensorial wave. Digital modulations also comes under sensorial wave. ASK amplitude shift keying, FSK frequency shift key shifting, and PSK phase shifting. Pulse modulation, it comes under discrete phase. FAM pulse amplitude modulation, PFM pulse frequency modulation, PPM pulse position modulation, PWM pulse width modulation. These are the modulation schemes in the compatibility in modulation. The next one is hybrid weight set design. Hybrid weight sets combine different symbol weight to optimize error performance and complexity. They enable flexible adjustments in modulation concentration based on channel quality and system constraints. Design constraints include minimizing symbol error rates with maintaining low decoding complexity. These are the hybrid weight sets design. Like when they sounds like a hardware audio, electronics questions, not modulation theory. Please clarify. Bluetooth plus wide headset modulation, RF auto transmission, noise reduction, signal condition size. These are the actual meant of hybrid headset. It is also works on the electronics. These all comes under the hybrid headset. Hybrid weight set is also like that only, that is enable flexible adjustments in modulation concentration based on the channel quality and system constraints is hybrid weight set design. Low complexity modulation techniques such as gray code is simply gray code simply constellation mapping, and reduced symbol sets are used. These methods aim to lower computational load while maintaining acceptable error performance. Hybrid weight sets further contribute by region in the signal space. These are the hybrid weight sets future contribute in hybrid weight sets future contribute by simplifying decisions regions in signal phases. These are the low complexity modulation techniques. Implementation of hybrid weight set modulation. Implementation involves design modulation concentrations that combine differential symbols weight effectively. Hardware constraints influence the choice of modulation parameters to ensure low complexity. And it is also hybrid weight set modulation is a low complexity digital modulation techniques that, and it combines symbols mapping and weighted summation, uses different weight sets to represent different data symbols, achieves rate compatibility useful with hybrid ARQ. These are the hybrid weight set. It is mainly proposed for wireless communication systems, low power devices, systems needed flexible data rates without changing bandwidth. Is comes under the hybrid weight set modulation. The basic principles are in the weight set modulation is, instead of directly mapping bits to PSK symbols, input bit signals a weight set. Selected weights are applied for basic signals. These symbols weights combination, and the mathematically S of t is when you these weights selected. These are the implementation of hybrid weight set modulation. Performance and analysis and benefits. Hybrid weight set modulation other improved spectral efficiency compared to fixed weight schemes. It provides better error performance under varying channel conditions with magnetable complexity. Overall, the approaches enhances system flexibility, robustness, and energy efficiency. These are the performance analysis and benefits. Challenges and future direction. Design optimal system. Hybrid weights. Set involves balancing complexity, performance, and implementation costs. Future researchers may focus on machine learning techniques for adaptive weights set selection. Integrating this approach with emerging technologies like massive MIMO and millimeter wave systems presents promising opportunities. Thank you.